All right, everybody, welcome back. This is part 2 of quadratic functions in Vertex form. Obviously, you didn't get enough the first time because you're back for the second round. Just a quick review that when we talk about quadratic functions, we're talking about any function, any polynomial function that has a degree of 2, which is the highest value exponent is 2. And so we have this general form. This is one of the general forms which we call Vertex form. For writing our quadratic functions. And so we learned last day that each of these pieces, A, P, and Q, are going to have different effects on our overall function. So you might recall that A really does two things. So A is going to affect both the steepness, so whether it's narrow or wide. So maybe I'll just call that the width of the parabola. And remember that a larger number makes it more and more narrow, and a smaller number makes it more and more wide. But it's also going to affect the inversion, or which way the parabola opens, whether it opens upwards or whether it faces downwards in its opening. The P value is going to shift, but it's only going to shift things left and right. And just a reminder too that there is a little negative sign there, and that negative sign just means that when you have when you subtract a number from x, you're actually going to be shifting to the right, and when you add a number to x, you're going to be shifting it back to the left. And then the q value here on the end is going to be involved with shifting up and down. And I can see that right is spelled with a T. Perfect. Okay, so what you should hopefully be able to do, if you're not there yet, this is going to be great practice, is you should be able to look at a function that's given to you, and without using your calculator, and without using a table of values, you should be able to just sort of create a representation of that graph on a page, just a rough sketch of what it looks like. It doesn't have to be perfect, but we should be able to do it just by looking at our function. So the first thing we always want to do is we always want to locate our vertex. Remember the vertex, that's kind of like home base for our parabola. That's going to be that point of inflection for our parabola. So I can see that my P value is 1. I'm subtracting 1 here, and my Q value is 4. That means my vertex, which would normally be at 0, 0, is going to be shifted 1 space over and 4 spaces up. So my vertex for number 1 is going to be located here. I can see that the A value is basically 1, and it's a positive 1, so that means it's going to be opening upwards, but it also means it's not going to be stretched or compressed in any way. And so that's going to follow the normal rules for a parabola. And that normal rule was when I go over 1 space, then I'm going to go up 1 space. So over 1 and up 1. But when I go over 2 spaces, I'm going to go up 2 squared. I'm going to go up 4 spaces. So over 2 and up 1, 2, 3, 4. And you can repeat that pattern, but that's probably enough. Don't forget though that it's going to be symmetrical. So when I go to the left, when I go over 1 space to the left, I'm going to go up 1 squared space, which is 1. And when I go over 2 spaces, I'm going to go up 2 squared is 4 spaces. And so I'm going to get this parabolic shape that looks something like this. Okay, so I'll draw in my curve. All right, let's do these next couple. Now would be a great time for you to just hit pause on the video, try these, and then actually try them right now when you hit pause right now, and then come back and see how you did. So now that you've come back from pause, let's try this next one. We're going to locate our vertex first of all. So it's x minus 4. That means I'm shifting to the right again. So I'm shifting over 1, 2, 3, 4 spaces. And then I've got a minus 1 here on the end. That means I'm going to shift down 1 space. So my vertex is going to be located over here. In fact, I might write in my vertex location is going to be 4, negative 1. Maybe I'll write in my vertex for my other one here. That was 1, 4. Okay, now that I got my vertex, I'm going to find, see if there's an inversion, which there is. Got a negative sign, so it's flipped upside down. And then there isn't any expansion because there's the number in front, A is 1. It's negative 1. So when I go over 1, I'm going to go down 1 squared is negative 1. And then when I go over 2, I'm going to go down 2 squared is negative 4. Same thing to the left, over 1, down 1, over 2, down 4. And then I can fill in my curve. I just run out of graph paper, that's okay. All right, let's try C. So for C, again, I'm going to find my vertex first. This x plus 3, remember that sign here can be misleading, but the fact that it's plus 3 means that P is negative 3. So I'm actually going to shift over 1, 2, 3 spaces to the left. And then negative 5 means 5 spaces down, 1, 2, 3, 4, 5 spaces downwards. So my vertex will be located here at negative 3, negative 5. And my A value is positive, so I'm faced upwards, but it has a value of 3. So instead of the normal pattern of over 1, up 3, over 2, up 4, I have to multiply that by a factor of 3. So I'm going to go over 1, but I'm going to go up 3. 1, 2, 3. And I'm going to go over 2 and up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Same thing on the other side. Over 1, up 3, over 2, up 12. And now I'm going to fill in, and this is going to look funny because it's really steep, but that's okay. Nobody's judging me. Fantastic. All right, last but not least, y equals 1/2 x squared, x minus 2 squared plus 4. So my vertex, I've got x minus 2. X minus 2 means I'm going to shift to the right, so 1, 2 spaces over. X plus 4 means I'm going to shift up 4. 1, 2, 3, 4, and it's getting busy over here, but there's my new vertex. My vertex is at 2, 4. It is facing upwards because A is positive, but it is a half. So I'm going to need to multiply my normal pattern, over 1, up 1. I have to multiply that by a half. So I'm going to go over 1 and up only a half. Over 2 and up, 2 squared is 4, but a half of that is only 2. And then over 1, up a half, over 2, up 2. And then I've got this sort of shape here. Okay, a little hectic, but you get the idea. So hopefully you're at this point, you should be able to kind of sketch those graphs out. The other thing we might have to do is just analyze the graphs. And a couple things I want to point out, that for any parabola, every parabola has a vertex. Every parabola has an axis of symmetry, which is a line that we could draw, a vertical line that we could draw that would cut the parabola directly in half. You could imagine, if we just take this part C, this red graph, you can see that my line of symmetry is right here. And no big surprise, the line of symmetry happens right at the vertex. So a vertical line that cuts through the vertex is going to be symmetrical on either side. The other thing that each parabola has is either a maximum or a minimum value. So you can see, for example, that this graph in red has a minimum value. It gets down to negative 3 and it doesn't go any further because it goes up in the positive in the other direction. Whereas this green graph has a maximum value. The maximum value happens over here at y equal to negative 1, because after it gets to that maximum value, it heads down the opposite direction. So the direction that it opens is going to be an indication as to whether it's got a maximum or a minimum value. Okay, so what we should hopefully be able to do at this point as well is just looking at the function that we're given, we should be able to figure out a whole bunch of information from it. And remember that the vertex form, the basic vertex form is y equals a x minus p squared plus q. So for our first function here, we can see that the a value, there's nothing up front, but that means that there's just a positive 1 there. So the value for a would just be 1. P, it's tempting to say that P is negative 2, but remember that there's a negative sign already built into that equation. So the value for P in this case is just 2 because we're subtracting positive 2. The value for Q is this one at the end here, which is 4. And our vertex is just going to be the location of P and Q, which is 2, 4. Now the axis of symmetry is going to be a line. The axis of symmetry is going to be a line that goes straight up and down right through our vertex. And so that axis of symmetry is going to happen right at x equal to 2. And then the direction of opening, since a is a positive value, then this is going to open upwards. And if it opens upwards, then that means it's going to have a minimum value, but no maximum, because it can go up in each direction. So it's going to have a minimum value, and that minimum value is going to happen right at the y coordinate of my vertex. The minimum is going to happen at y equal to 4. Okay, so again, this would be a great opportunity for you to hit pause on the video, see if you can do the next section, and honestly hit pause and see if you can do the next section, and then let me catch up with you in a second. Okay, welcome back. So for this next function here, the value of a is negative 3. The value of P would also be -3. The value of Q would be 4. The vertex is located at -3, 4. The axis of symmetry runs right through x equal to -3. The direction of opening is going to be downwards. And the maximum or minimum value, it's opening downwards, which means there's a maximum value, and the maximum value is going to happen at the y location of our vertex, so y equal to 4. All right, last one. We've got an a value of 1/2. We've got a p value of 4, a q value of -3. We've got a vertex, which is located at 4, -3. We've got an axis of symmetry at x equal to 4. We've got a direction of opening, which is upwards because a is positive, and that means we have a minimum value located at our y coordinate of our vertex, which is y equal to -3. Okay, so last thing we're going to look at, we've gone from the equation to the graph, and we also want to be able to go from a graph back to the equation. So we should be able to figure out our way forwards and backwards. And so we'll look at these two functions here. Let's look at this blue one first. Okay, so let's call this number 1. I'll do it off here on the side here. So the first and most obvious thing we're going to do is we're going to locate the vertex of our parabola. Just be careful here. Look at the scale on this side. Not every box is 1, every 2 boxes is 1, so just keep that in mind. So the location by vertex is going to be at +1, -3. And so right away, I know that if I'm trying to write my equation in this form, so I can write y equals a, x minus 1 squared minus 3. But I don't know the a value, and it's hard to just look at it and know whether it's been stretched or compressed. So the simplest way to do that is to identify at least one other point. So you can see here, if I look at a point where it crosses, like maybe this point right here seems to cross that. So that point is located at 2, -1. What I can do at this point is, since I know it goes through that point, and I know that I know everything here except for my a value, I could substitute in the x and y values and then solve for a and see what I get. So for example, I could put in here a -1 for y, so -1 equals a, put in a 2 for x, 2 minus 1 squared minus 3, and then just work everything out. So -1 equals 2 minus 1 is 1 squared, is just going to be 1, which is a minus 3, and then add 3 to both sides, and I end up with a is equal to 2. And so my final equation here, my final function is just going to be y equal to 2x minus 1 squared minus 3. Right? So let's do the same thing over here for this second function. I should point out, actually, just before I move on, that this value of 2 that I got for a, that seems to make sense. That graph looks like it might be a little bit compressed. It certainly is facing upwards, and that's what we would have expected. So we would have expected a positive value. So for the second function here, I know that I've got my vertex, and my vertex is located at -2 and then +1. So right off the bat, I can start with y is equal to a, and then x plus 2 squared, and then +1. And all I need to do now is identify another point that I could substitute in to find my a value. So maybe I'll use this one right here. That looks like a nice easy point to use. It doesn't matter which one you use. And so this point is at 0, -1. So I'll put in my values here. -1 is equal to a, 0 plus 2 squared plus 1. And so this becomes -1 is equal to 2 squared is 4, so 4a plus 1. I'm going to subtract 1 from both sides, so I get -2 equals 4a. I'm going to divide by 4, and I get a is equal to -2 over 4, which is really just -1/2. And so long story short, I substitute my a value back in, and I get y is equal to -1/2 x plus 2 squared plus 1. And again, that a value makes sense. The graph looks like it's a little bit stretched this way. It's definitely upside down, or it's inverted, so it should be negative. Okay, that's it for part 2.